NASA's been doing this for 50 years. Apollo astronauts, space shuttle missions, now Orion. They wrote the book on spacecraft recovery. But when SpaceX brings Dragon home, it takes less than an hour. The fastest on record? 27 minutes flat. NASA's Orion for that exact same ocean landing? Nearly 5 hours. So what's SpaceX doing that NASA, with all their decades of experience, somehow isn't? Let's find out on today's episode of New Space Review. December 11th, 2022. Orion comes screaming back to Earth at 11 kilometers per second. That's faster than any crewed spacecraft we've seen in half a century. It takes over 5,000 degrees of heat on re-entry and splashes down perfectly in the Pacific. Mission accomplished, right? Then something weird happens. The recovery team just sits there. 2 hours go by before anyone even gets close to the capsule. They're running what NASA calls detailed on-water inspections, checking heat shield data while Orion's just floating out there. 3 more hours pass as they attach tow lines, stabilize everything, and inch the capsule into the USS Portland's well deck. 5 hours total from touchdown to recovery. Now look at what happened in September 2024. Crew Dragon hits the water off Florida, carrying Sunita Williams and Butch Wilmore. 27 minutes later, the capsule's on the recovery ship. Astronauts are out, and medical teams are already checking them over. Not hours, minutes. That's not a small difference. That's a completely different way of thinking about how this whole thing should work. Here's something most people don't realize. SpaceX picks their landing zones really carefully. Dragon usually comes down 20 to 200 nautical miles offshore. Close enough that recovery ships don't have to travel forever, but far enough out that debris from the trunk isn't going to hit anyone on the coast. Orion's Artemis I landing was different. Originally, they were aiming for spots 50 to 300 miles from San Diego. Weather changed the plan, though, pushing them way farther south, somewhere between 300 and 550 kilometers offshore. Made sense for safety. Calmer water, better conditions for the Navy ships. But here's the trade-off. Your recovery vessel has to travel twice as far, and that means you're automatically adding hours to the clock. NASA made the right call for safety, but speed? That wasn't even on the table. Go aboard one of SpaceX's recovery vessels like Megan, and you'll find maybe 20 to 30 people total. Engineers, divers, medical staff. Everyone knows their one job. These aren't military ships with layers of protocol. They're converted oil support vessels that SpaceX rebuilt specifically for Dragon recovery. Smaller, faster, focused. Compare that to the USS Portland. It's a massive amphibious assault ship built for military operations. Hundreds of crew members, Navy procedures for everything. And this flooded well deck system, where you have to carefully let water in, position the capsule, then pump it all back out. Every single step takes time. SpaceX's method? Crane just lifts Dragon straight up onto an open deck. Done. Astronauts walk out into medical right there. Usually there's a helicopter already waiting to fly them back to shore. For cargo missions, experiments get to Kennedy Space Center while NASA's still towing Orion around. It's not that NASA's doing it wrong. SpaceX just refuses to accept "this is how we've always done it" as a good enough reason. When Megan finished its last mission on Crew 9, SpaceX didn't throw a party. They retired the ship. Why keep operating something that costs more than newer alternatives? That's just how they think. April 2008. Korean astronaut Yi So-yeon's coming home on Soyuz TMA-11. Something goes wrong during re-entry and the capsule ends up on a ballistic trajectory. She gets hit with 10 Gs. Survives, but she's in serious pain. Needs immediate hospitalization for her back. Think about that for a second. What if she'd been stuck bobbing in the ocean for 3 more hours? Dragon's 27-minute recovery isn't just some bragging right. It could literally save lives. Astronauts coming back from space aren't in great shape. Their bones have lost density, muscles have weakened, their cardiovascular system needs time to readjust to Earth's gravity. Every extra minute floating in a capsule increases the risk something goes wrong. SpaceX runs it like an emergency response. Fast boats go out first to check for fuel leaks or toxic vapor. If there's a problem, they handle it right there with specialized gear. Once it's safe, Dragon gets lifted, hatches pop open, and astronauts get medical attention within the hour. NASA takes longer because they're checking different things: extensive structural analysis, heat shield inspection. They want all that data before they even think about opening the hatch. Different mission priorities, different timeline. Dragon and Orion weren't built for the same job. Dragon's around 9 to 10 metric tons, and it's basically a taxi service to low Earth orbit. Orion's 10 to 11 metric tons, and it's designed for weeks-long missions to the moon. When Dragon comes home, it's re-entering at about 7.5 kilometers per second. When Orion returns from lunar missions, it's hitting 11 kilometers per second. That's Apollo-level velocity. Those extra kilometers per second matter more than you'd think. Higher speed means more heat, more structural stress, more physical trauma to the crew. NASA's slower recovery process isn't them being inefficient. They're dealing with astronauts who just went through something Dragon crews never experience. The medical protocols are different because they have to be. And that's the real insight here. Both systems work great for what they're designed to do. SpaceX optimized for commercial operations, where you need fast turnaround and cost efficiency. NASA optimized for deep space exploration, where you get one shot and it has to be perfect. SpaceX didn't always plan on ocean landings. Elon originally wanted Dragon to land using Super Draco engines, propulsive landing straight onto a pad. No parachutes, no water, no recovery ships. Just rockets firing for a precision touchdown on solid ground. NASA shut that down. Not because they were playing favorites with Boeing Starliner, which does land on the ground. It was about risk. Propulsive landing was too new, too unproven. And Super Draco runs on hypergolic propellants that can explode if something goes wrong. NASA wanted parachutes as mandatory backup, which made the whole propulsive system dead weight. SpaceX dropped the idea in 2017. Starliner went the other direction. Parachutes plus airbags for ground landings, just like Soyuz has been doing for decades. NASA approved it because the system has proven track record, not because it's better, but because it adds diversity to their options. But look at the results. After almost $5 billion in development, Starliner's flown one crewed mission. Dragon's done dozens. Starliner's next flight in April 2026? Cargo only. That tells you something about their confidence level. And even if that mission works perfectly, Would you trust it with sensitive science experiments or biological samples? The physics say you probably shouldn't. Ground landings hit hard even with airbags. You're looking at 5 to 6 Gs on touchdown. Water absorbs that impact energy way better. Russia's Progress cargo ship can't even attempt to return cargo. It delivers supplies to the ISS, gets loaded with trash, and burns up over the Pacific. Even if it had a heat shield like Starliner, it still couldn't safely bring back fragile experiments. The ground just hits too hard. Soyuz astronauts have talked about rough landings damaging equipment and causing injuries. Human bodies can handle it better than sensitive electronics or chemical experiments that need stable conditions. That's why Dragon dominates cargo return missions. Splashdown isn't just safer for crew, it's gentler on the science. So SpaceX didn't figure out some secret NASA missed. They built what commercial spaceflight needs: fast, efficient, repeatable. NASA built what deep space exploration demands: methodical, thorough, maximum safety. The 27-minute recovery versus the 5-hour recovery? They're not competing. They're solving completely different problems. That's what matters here. If this breakdown was useful, hit that like button and subscribe to New Space Review. We're tracking the space industry's biggest moves as they happen. Drop a comment on which recovery method makes more sense to you. Thanks for watching. Don't miss what's next. Click that end screen for Pad 2 completed. Starship Flight 12 so close, sooner than we thought. Because the next Starship launch is coming faster than anyone expected.